Um, Today we're going to, or I should say now, lots happening today. Right now we're going to do an overview of the governance contracts and generally the sort of engineering work that's gone into the new Arbitrum governance system that was revealed yesterday and will be live on Thursday. Maybe to start, let's do quick intros. You want to start, Chris? Just who you are, what you do.
Hi, I'm Chris. Yeah, I work on the blockchain engineering team here at Arbitrum.
Cool. And Harry?
Yeah, Harry here. Also work on the blockchain engineering team here.
Cool. So to get into things, we should say, the term governance gets used a lot in this space for all sorts of different things. Even DAOs, this is an Arbitrum DAO, gets used a lot. So let's just start by maybe talking about what we mean when we say that our governance system has executable governance. On-chain executable governance. So that's all implemented. It's actually live right now. It's just the tokens will be distributed Thursday, and that's when it really becomes active. But it's all there. Maybe to just kick things off with you, maybe Chris, just to intro us, like, how would you even define executable governance, or what do we even mean by that to get us started?
So for executable governance, I guess we're talking about things that can be governed or controlled by smart contracts themselves. So we have some sort of data that can be executed on chain and cause whatever the proposal is to be the result of some sort of on-chain execution. Keep using the word execution recursively, I think there, but
I think it's clear enough, though. Yes, I mean, I don't, we can sort of, without defining execution, we can say that the full operation is carried out on chain via smart contracts, as opposed to alternatively governance as more of like using the blockchain for, I don't know, some sort of social signaling. So in this case, executable governance being it's all actually carried out on chain. In terms of like the role of the executable governance. So we have, you can look in our docs, we've established like the constitution of the Arbitrum DAO, which lays out, in part sort of the values and social expectations of what's going on, but also explains like the technical role that is entailed by controlling Arbitrum chains, let's say. And there's kind of a notion of chain ownership that we use broadly, and we can sort of maybe talk about like some examples of what sort of executable actions a chain owner might do. Probably there's actually a few things. So like in order to, we've already transferred ownership to the DAO. Actually transferring ownership, there's a few different things. But at its core, some of the more important stuff here, I guess you could say, is the smart contracts themselves that define the Arbitrum system are upgradable, and the sort of ability or the affordance to upgrade them is something that is granted to some entity. So that used to be sort of like an admin multisig. Now that is the DAO itself. There's other things like that, certain privileges, certain affordances too, that can do very important things for an Arbitrum chain that we grant to this chain owner. And now, as of now, all of those literally belong to the DAO. And these actions are entirely executable on chain. In terms of implementing this, and this, as far as I know, I don't want to make too strong of a statement here, but I think it's in terms of the properties it has, I think it's the first time a rollup has these properties that we're going to describe. I think if I say that vaguely enough, it's probably true. In terms of a true implementation of governance, there's a question of like what properties are even like necessary or what we want to have, and the Constitution again explains this. But basically, if you're familiar with governance or DAO governance, it has it works some of the ways you would probably expect. There's this token, we can make proposals. Those proposals, there's a voting period, you vote, if they pass, something happens, right? What's the sort of additional engineering work on top of that? So one of the things was essentially we want to make sure that, obviously we hope that the DAO is aligned with the good of the Arbitrum community, and hopefully something that passes, will be something that is generally seen as like unequivocally good. But in case that gets compromised, or in case that, you as a user of Arbitrum sort of disagree with an upgrade, don't like an upgrade, and disagree with the direction, one property we wanted to preserve is that you have an opportunity to kind of exit the system before the upgrade takes place. Which sort of ensures that, even if, as we introduce this new governing mechanism, even if it goes haywire, there's an opportunity there to sort of rescue your funds. And a lot of the technical work is sort of making sure that that kind of works and functions properly. Is that a fair starting point? Anything else to add there from anyone?
Yeah, I would say that. So your main point there was to give users a chance to a choice on whether or not they want to remain in the chain after a proposal has passed, but before the proposal is actually executed. And I think one of the motivations for that you spoke about is the assets that are controlled and governed by the DAO. So to give maybe a bit more of the gravity of the situation, so the DAO has full control over the smart contracts that are on L1. So those in there, those that's where the bridged funds are. So if you have funds on Arbitrum, those funds are going to sit in the bridge. And if a proposal passes that you disagree with, it can actually affect where those funds in the bridge go. So you might say, okay, I want to withdraw my funds before that proposal passes and get out. Other things it can do, it can upgrade those contracts. It controls the whole of the governance system itself. So the DAO controls itself, its own governance contracts. It can also control the chain owner role on Arbitrum 1 and on Nova, which sets fees and where those go. So and it can change as well a thing called the WASM root, which is in the rollup contracts on L1 on Ethereum, and that defines actually what the state transition function of Arbitrum 1 is. So what Arbitrum 1 is actually doing is controlled by that. So there's all this power that the DAO has, and as an individual user, you can be affected by that. You're affected by the choices that the DAO can make, because it's controlling the whole of Arbitrum and everyone's assets that's on it. So because of that, it's very important that each user who's on Arbitrum has the opportunity, if they want to exit from the chain to go to Ethereum or go to another chain with their assets before the proposal is passed. So there's a long period whilst the proposal is taking place and being voted on, but there's also several periods after the proposal has passed. So a proposal gets finalized after the voting period, and then after that there's a bunch of time periods and a whole process between actually passing in a vote and actually being executed and doing the upgrade. So that was just a bit more detail. Did you want to go back there, Daniel?
No, I think that's a good summary. But as you say, you can imagine in principle an upgrade could do arbitrarily anything, including something arbitrarily malicious. Which obviously, if it's overt as like stealing funds from the bridge, we would expect the DAO to not pass that proposal. But the idea is, whatever it is, if something passes, there'll be this opportunity to exit the system. So that's kind of a core property we wanted, just sort of in principle that's outlined in the Constitution. And then, we can get into sort of what that looks like in terms of how these contracts work. So let's get into that. So I guess the first thing is, so obviously, you need to, in order for this to make sense, in order for their users to have an opportunity to exit the system, which, most importantly maybe means being able to withdraw their funds, there has to be some delay. A delay between when a proposal is officially accepted by the DAO and when it's actually effectuated, I think is a legal term. I might be using that wrong, but when it actually, gets put into place, takes effect. So that should be some delay there. Now, with certain like DeFi applications have done this. I think Compound did at one point, just a layer 1 application where an upgrade, they could arbitrarily upgrade it, but they put something like a 1-day delay on an upgrade. So an upgrade's kind of broadcast on chain. It's published on chain. Anyone who's watching can notice that an upgrade would take place, and users have like 1 day to withdraw. Now, with layer 2 systems, this gets a little trickier, or with optimistic rollup systems like Arbitrum, because there's sort of already a delay period baked in. So if you're familiar with Arbitrum, or you've used Arbitrum 1, you know that if you try to withdraw your funds directly using the withdrawal mechanism, you have to wait about a week for them to be finalized. And maybe let's just maybe look at that for a second. Maybe Harry, if you're maybe just like briefly explain for those who aren't familiar why there is even this dispute period. If Harry's still there, he may have fallen asleep. He was up all night last night. Hi, Harry.
Yeah, sorry, I just can't find it, but all right. Yeah. So are we talking about the dispute period? Right?
Yeah, let's just start with, just for background, why there even is this dispute period to begin with, and then we'll get to how the governance system kind of works around it or uses it.
Yeah, so like as an optimistic rollup, so like the normal workflow is that you get people like transact with the sequencer, and then the sequencer will put the transaction batch into the layer 1 inbox of the Arbitrum rollup or Nova. So like those transactions are like the input to like the system, and then like we have a role called the validator. They will actually go like read those things in the inbox, and they try to like run it against the layer 2, the nitro stack, and then you just calculate the resultant state of this kind of input to like over a state transition function, and they will go get the output and post it to layer 1. But the thing is that because like the L1 contract actually can't know that they get like they actually post a valid like state transition, so you have to like leave them like some time for people to have transit. So that's why we are like an optimistic rollup. Basically, if like in 7 days no one is challenging that this is wrong, then we assume that's correct and the system proceed, and everyone can like do withdrawal from that like state root. But then if like during that 7 day there's like someone try to like want to like dispute this, like saying okay, I don't think this state root is wrong, and we go into like an interactive proper process to try to resolve it by setting the state change, and then to find the point that we disagree on and execute the ones that proof. But that's like the other thing. So why we need to have like the 7 days is that we have to give time for people to react and to like just like to change like something that to give them a chance to change like a embedded root there.
Yes, exactly. So the 7 day, as you say, it's this core property of the system where other validators need time to react. Sorry, 1 second. There we go. Yes, so we need to give other validators time to react. 7 days is kind of the sort of the decision the community has agreed on. It's you know, somewhat arbitrary, but you know, you certainly need some time. Optimistic rollup to 7 days, and then in the case that you described where there is a challenge, it could end up being longer, right? And this period, you can just sort of think of it as particularly how long it takes messages going from layer 2 to layer 1 to finalize, which includes withdrawals. So at the very least, you know, we have to work around that. So for example, if we just said, okay, there's a governance, the governance can pass votes, or you know, can pass proposals via votes, and then once they pass, you have 1 day to withdraw your funds. This would be insufficient because all you have is a day to sort of initiate a withdrawal. Your withdrawal won't be finalized on layer 1, and then if the governance proposal upgrades the layer 1 contracts, you haven't successfully been able to withdraw before whatever something happened that you didn't like. So the delay period kind of has to work around at least that. But for you know, more subtle reasons, it's not even enough to just add a week of delay, because in the case of a challenge, in principle, a delay could sort of keep extending this this delay period that you have to wait when withdrawing. So that's sort of some of the context of what we have to work around here. So we can kind of maybe start going through the life cycle of a proposal, starting with after it passes. So there's a few sort of intuitive steps about, okay, you vote, you debate, you go on a forum, people with you know, with votes delegated to them can vote and so on. When something passes, well, yeah, let's just go through the life cycle here. Well, maybe Chris, if you want to just sort of pick up from here. So let's say we're at the point when, you know, a vote officially passes. again, maybe in another governance system, another type of governance system might just execute it right here. But in order for us to have this delay, we introduce a few more steps. So what is the next step after a proposal officially passes?
Right. So, yeah, and just to be clear on what you and Harry were saying as well, this withdrawal delay period around optimistic rollups is something that Arbitrum has always had. It's not something that we're introducing with the DAO or anything like that. It's just how optimistic rollups work, and we've always had it there. So yeah, as Daniel and Harry said, this is something we've got to work around and consider when we're doing this proposal lifecycle. So to go back to Daniel's question, if you have a proposal that's been voted on by the DAO and they've decided to pass the proposal, the proposal itself contains the data which describes exactly what the proposal will do. And once it's been passed, that data cannot be changed, and the result of what that data will do cannot be changed. It'll be executed directly through a set of smart contracts, which can't be changed either unless via previous proposals or things like that. So it's completely deterministic after the proposal has passed. And the first step that the proposal goes through is it goes into an L2 time lock. So the governance itself, the DAO voting system, already exists on Arbitrum 1. It doesn't exist on Ethereum mainnet. All the voting and delegation and the token and things like that are on Arbitrum 1. And so the proposal passes in the governor contract on Arbitrum 1 and moves through into this time lock. Once it's in the time lock, it waits there for 3 days, after which anyone can trigger it to move to the next stage. And the next stage is that it's going to start an exit from Arbitrum 1 back onto Ethereum mainnet. And it does this, it goes through the waiting period that we have for optimistic rollups. I'm just going to briefly describe each of the stages, and then I'll come back for a bit of the rationale behind why each of them are there. So it goes into this exit process via which all L2 to L1 messages go, all ARB1 to Ethereum messages do this, and it waits there until that assertion associated with that withdrawal, with that exit, is finalized. No one has decided to challenge it in this challenge process, or they have challenged it and all the challenges have been resolved. After that's happened, again, anyone can come along and execute the deterministic data, which is in the Ethereum outbox, and that sends the data into another time lock, which is on Ethereum mainnet, and it sits in that time lock again for another 3 days. And after that 3 days, again, anyone can come along and execute it, and at that point, that's when the actual sort of meat of the proposal occurs, and whatever the DAO wanted to happen will actually happen at that point. We've passed through all the delays.
Yeah.
So if we,
no, I was just going to add, maybe you were gutting here in a second, but basically, we passed through all the delays, so whatever needs to happen can happen. And interestingly, if the thing that needs to happen is something at layer 2, we send another cross-chain message. So we went from layer 2 to layer 1 for this delay. Now we go from layer 1 back to layer 2, just so we can finish executing. So we kind of, in our docs and stuff, we call this a round trip upgrade. But also if the governance action itself happens on layer 1, it can just sort of happen there at that point.
Yeah, that's right. And the principle is that anything that can affect users has to go through all of these delays in order to provide to ensure that a user will be able to exit before they're affected by the proposal. So if we go back to the first time lock delay on Arbitrum 1, the reason that's there is because you need to be able to exit the chain before the proposal starts its exit.
Yeah, that's right.
Yeah.
So
I always get the two. Yeah, go ahead.
Sorry to interrupt, but just to in other words, just to add color there, basically the idea is if the proposal itself, as long as the proposal itself comes after you say a user withdraws, and we require that the proposal itself, this L2 to L1 message has to be confirmed to continue. It's almost like if we call them assertions on Arbitrum, these claims about the state of Arbitrum, if the assertion that concludes the proposal is confirmed, then so is all of its earlier stuff, which now earlier stuff includes 3 days of time for users to withdraw. So that's sort of the thinking there.
Yeah, maybe it's better actually to work backwards. If you think about what the user wants to do, the user wants to exit the chain. So they need to react to what the proposal is, and then they need to start a withdrawal from the chain. And that's going to take a certain period of time. So we know that the amount of time must be at least equal to the withdrawal time for the user, plus their amount of time to notice. So the amount of time that it takes to withdraw is this withdrawal time, which is a bit variable depending on whether the withdrawal gets challenged. So in order to be sure that you have always at least the same amount of time as the proposal withdrawal time, the user withdrawal time, sorry, you force the proposal also to go through a withdrawal. And as long as the user starts their withdrawal before the proposal starts their withdrawal, then the user can guarantee that their withdrawal will complete before the proposal's withdrawal will complete.
Yep.
It's not this on the surface sounds like, okay, but then why do I need the L1 time lock? And the reason behind that is because you might think, okay, well, the user has started their exit before the proposal exit, so they should complete before the proposal exit, and then they'll have time to exit the chain. But a complication occurs in that if the user's early exit is challenged by someone challenging the roll-up attestation associated with that exit. And what that does is it causes their exit to be delayed, and any exits that are queued behind it. So the proposal exit will also be delayed, but it's only delayed because a previous exit is also delayed. It's not delayed because anyone's challenging it. So I'm a user, I start exiting the chain, someone challenges the attestation associated with my exit, and now we've got to wait while this is resolved. In the meantime, a bunch of attestations are piling up behind mine, and no one's challenging them, but they all have to wait until mine is resolved. As soon as mine is resolved, all of the ones that were waiting have been through at least one fraud-proof period, at least, so they all become valid for execution at the same time. So then we end up with a race condition between the proposal and the user's exit. Both are executable at the same time, and the user is racing against the proposal. So that's why we had added an additional L1 time lock on Ethereum, such that even if this situation occurs, the proposal will be going into a time lock, whilst the user won't be. So the user can always be sure that they won't be in a race condition with the proposal.
Yeah, there you go. And there's all of the sort of governance protocol enforced delays. It's kind of 3 of them that we covered there. The proposal itself might decide to include additional delays if it wants to, but at the very least, it has to go through those. So yeah, so like, I guess in summary, it's like we start with just a 3-day period enforced on the L2 time lock, which guarantees, as long as you act within 3 days, it guarantees that you can sort of initiate your withdrawal before the governance proposal itself makes a message, which means by the time the governance proposal is confirmed, so will your withdrawal be. And then we just wait for an actual message to confirm, which we know has to, that takes a week or perhaps longer, but however long it takes, again, this guarantees that everyone's withdrawals will get confirmed too. The amount of time it takes, by the way, I mean, there's some a research post that we put out recently. I think Ed and a few others put this together, arguing for ways that we might want to reduce this period. So it could, we could imagine optimistic rollups having a delay period shorter than 1 week. There's also some work we're doing where we can sort of decrease the upper bound, right? So right now it could be a week, but it could be, it could be a few weeks longer. Assume we might be able to put a hard upper bound, but whatever it is, we won't have to adjust these governance contracts. It just waits however long it waits. However long it takes to get confirmed, it does that. And then, finally at L1, at layer 1, as Chris said, we want to make sure that you're not sort of racing against a bunch of assertions that are about to be confirmed for you to sort of finalize your withdrawal. You can imagine an upgrade, that's trying to like steal funds from the bridge, let's say, and you're trying to take your funds out of the bridge. You don't want to be racing against that, so we just force an additional 3-day delay period. So if you
Yeah, I was just going to say that whilst we're still talking about the time locks, you might also think that if this L1 time lock exists and that's always going to occur after the proposal exits from the outbox, does the user need to actually start its exit before the proposal starts its exit? Couldn't they start afterwards? Because once the proposal hits the L1, it's going to go through this time lock. So why do we need the L2 time lock as well as the L1 time lock? And the reason for that is that if the proposal starts its exit and you start its exit afterwards, then someone could come along and challenge your exit, but not the proposal's exit. And that would mean that your exit would be delayed whilst the proposals wouldn't. So when it came for the proposal to now execute in the outbox, it would go into the time lock and it would wait there, but your exit would still be being challenged. So you might exit from your challenge period after the proposal has finished in the time lock. So that's why you need to always exit before, and you need the time lock on L1. So that's the motivation behind both sets of time locks.
Yeah, that's a good. Yeah.
Just also want to add that the L2 time lock also give the Security Council time to interfere if there's anything they need to take action.
Yes, for sure. And we should just talk a bit about the Security Council generally. So you want to explain the Security Council, Harry, since you brought it up?
Yeah, so we have in our governance system, we have two Security Council. One is a 7 of 12 multisig, and also another one is a 9 of 12 multisig. The 7 of 12 multisig is basically being able is they have the permission to schedule things into the time lock. So and the 9 to 12 multisig is a more require higher threshold because they can actually directly do upgrade and things that directly change upgrading the L1 and the L2 contract. So there's situation that, for example, there's a immediate security vulnerability that we discover and we need to patch the system immediately. This because Rollup is still a very new technology, and we are not even confident that there will never be bug in our system. So we still need a training wheel that's kind of help us to react to immediate security issues, because as we just said that there's a lot of delays. We have the L2 time lock, and we have the withdrawal period, and also 3 days in L1. So if we discover a 0 day in L1, it won't be enough time before we can patch it. Not to mention all the things that we have to pass the proposal is all public. So there's no way that one can just fix a vulnerability using the regular governance proposal workflow right now. So that's why we have the Security Council design to help us tackle those situations. Yeah, so as I talked about, there's two Security Council. There's one with slightly less threshold with the 7 of 12 multisig. They are able to schedule things into the L2 time lock. They're also being able to cancel things in the L2 time lock. The reason is that if there's a governance attack that for example someone that's happened in crypto before, someone tried to sneak a malicious proposal, and then they just roll it last minute and try to get it past it. Which there's another issue that we have mitigation for people, so you can't just wait for the last minute of the proposal to pass to just submit your vote, because the deadline will extend by it, so people can react to this kind of attack. But still, in the unlikely situation, someone managed to pass a malicious governance proposal. So the Security Council actually will still have a chance to cancel it in the L2 time lock when they see fit.
Yeah, exactly. And essentially, the sort of the governance is architected so that there's kind of this, we've been talking about this slow upgrade path that the DAO can use. That's fully permissionless. It requires various token delegated addresses to vote and things like that. But every step is permissionless. And then there's this kind of fast path, emergency upgrade path. That's the Security Council. This is just a 9 of 12 of largely independent entities. I think 9 of the 12 are completely external to off-chain labs, for example. And yeah, so it's like we're sort of introducing the DAO with this thing in place, and then, as we said, the DAO itself, as far as the affordances it has to change the system and upgrade, that includes upgrading governance itself, right? So all of the governance contracts are owned and upgradable by governance itself. The Security Council in particular, the DAO is going to sort of like hold elections as long as there is a Security Council, as long as it's still there, they'll be sort of elected biannually. And then, yeah, in terms of like how that evolves, how the Security Council trust minimizes, that's sort of a question for the DAO to make. But we wanted to release it with this architecture in place, so that there's both paths: emergency only fast path, and then the typical slower path that has the properties we described. And it's just sort of designed in a way so that you can kind of like, you can sort of just grant this chain ownership affordance we talked about to like this one contract essentially, and then everything kind of follows from that. The Security Council can do what it needs to do, and the DAO can do what it needs to do, which is the full kind of chain owner upgradability, things like that, affordances. So yeah, but no, yeah, the segue there, the point, just going back to these various delays, is yes, in the case of some sort of emergency, having these time blocks also is helpful. It gives more time for the Security Council to take action. Cool. So I think that kind of covers. I should also just say the other thing that is worth kind of saying here is this whole if you're a Solidity engineer or anything like that, and you want to look through these, if you want to look through the contracts, they're at the Arbitrum Foundation /governance, I think, on GitHub. So a lot of the moving parts you see are there to kind of enforce this this kind of delay, this round trip architecture. In the case of like a new chain that gets deployed, if the DAO maybe deploys an additional L2 or anyone deploys an additional L3, and you want to sort of be included in the same governance, there's really just like, it's done in such a way that you just sort of need this one contract that we call the upgrade executor, and you just sort of like grant the DAO affordances over that, and then you can give whatever you want to that contract. So it's fairly, whatever ownership means or control means of a certain chain, that is dependent on the chain. But as far as opting into the governance system, it's fairly hopefully it's fairly easy to reason about, and then it will just have these properties.
Yeah, you can just like give ownership to the upgrade executor, and then you basically like be part of the governance system.
Yes. Now, you shouldn't just, if you're just like a random DApp and you give ownership to the DAO, you shouldn't necessarily assume that the DAO will,
sure.
But yes, from a technical perspective, you can just give ownership. And we have the setup. Yeah, I should just say, we don't want to get too deep into this, but we have this set up in the Constitution that basically to have a new L2 that's governed by the DAO, you go through a proposal, and then the DAO can sort of grant a new L2, whereas an L3 you can just do completely permissionlessly. So, cool. Okay. Anything else on the like gov contracts themselves before we move on to some token and token bridging stuff? I think we covered the meat of it. Okay. Let's talk about the token. What everyone wants. It's really weird to be able to publicly just talk about the token, I have to say. It's been a secret for so long. It feels really nice. But we don't have to answer when token, because that's already been revealed. There's some interesting technical details about the token, and particularly its bridging architecture, that I thought we could get into. So maybe to start, let's kind of talk about how we handle token bridging in general on Arbitrum chain. So we've had a token bridge since we launched, and I guess just in brief before we get to it, this is the Arb token, and the way it's bridged is sort of unique in ways we'll get into. But maybe just like overview of, we have these terms like the token bridge is the whole thing, and then we also talk about like gateways. We're going to be using that term. Let's get into that a bit. Maybe Chris, do you want to step in? Maybe just like define token gateway. It's a hard question, but good luck.
Sure. So token gateway is a contract that both escrows tokens and creates the right data to send through the bridge to its counterpart on either Arbitrum 1 or Nova. So this is the way we have an underlying general bridge which accepts any kind of message data and will send it through from Ethereum to Arb1 or Nova. And these contracts know how to form data such that they can escrow tokens and then unescrow them on the other side, or mint and burn them in that way. And that's kind of what the gateways do.
Yeah, and yeah, exactly. Well done. That's a hard question. But yeah, it's sort of each gateway. The reason we have multiple gateways is this lets us sort of have, let's say, different means of bridging tokens, right? Different tokens might have different needs. You can imagine most ERC20 tokens on layer 1, when we talk about bridging, we just need to deposit and withdraw. Let's just, just to hand wave a bit, right? I want to be able to deposit and then get some representation of the token on layer 2, and I want to be able to withdraw and get the element token back on layer 1. So there's kind of a very, this generic kind of standard gateway we have that kind of just does that in the simplest way possible. But other tokens might want to do weirder stuff. So those tokens can sort of opt into a special gateway. So we, one that we had implemented when we released this was for wrapped Ether itself. Does some cool stuff. It kind of unwraps Ether and then deposits and rewraps it again for various reasons. Things like that. And some projects have built their own. I think MakerDAO has built their own special gateway.
Yeah, also LivePeer and
yes.
Lido.
Yes, that's right. Yeah, that's right. And Lido. So if basically, and all of these have to do is if there's special functionality kind of around bridging itself, you implement it, and then you can use that while still being part of the token bridge itself. So the token bridge is the overarching umbrella, and then all of the different ways of bridging are gateways, something like that. It's a little hard to explain, but hopefully that's relatively clear. So when it came to the ARB token, there was sort of a particular need. So the ARB token was going to be, we wanted it to be sort of native to layer 2, which is a distinction that matters for a very particular reason. The part of the one of the properties that it has is, it's deployed with a supply of 10 billion, and it can have at most 2% inflation per year. The DAO itself decides if they want to mint new tokens. So we want all of this stuff, the minting itself, the voting about the minting, to take place on layer 2. And what this means is the supply, the total supply, is something that we want sort of easily trackable on layer 2. And using sort of the other gateways that we use, that doesn't quite work if we had used the other gateways. And this is basically because the way the standard gateway works is it kind of treats the layer 1 side as the sort of canonical native token itself. So what you're doing when you're depositing is you're kind of escrowing it on layer 1. And when you get your withdrawal back, you're releasing it from escrow on layer 1. Whereas on layer 2, you're actually minting and burning the token. The bridge has the power to sort of mint and burn. So when you deposit, you mint and increase the supply. When you withdraw, you burn and decrease the supply. So layer 2 doesn't really have a good sense of what the total circulating supply is. For that, you can always just get on layer 1. And so that was sort of the new need that we had for the ARB token. Yeah, anything to add there? I don't know if that was clear, but yeah. Okay, cool. I see Mike's flickering in and out, but yeah.
No, I was just going to say it seemed pretty clear.
Okay, cool. So yeah, so let's get to, so this and this this feature for other, what this gets to, what we built for this for the ARB token, we call the reverse token gateway, kind of colloquially, and which is something that kind of has been requested from other teams for various other reasons, where they wanted, for one reason or another, they wanted to deploy their token directly to Arbitrum, but then still have it bridgeable to layer 1, as opposed to having a token deployed to layer 1 and then bridging it from there. So here this is the first time, we actually implemented that and used it. And yeah, the basic idea, well, yeah, maybe Chris, if you want to just explain the basic logic there. It's kind of intuitive, but.
Yeah, sure. So in a normal gateway, you escrow tokens on Ethereum because that's where they were originally minted, and then you mint a new representation of them on Arbitrum 1 or Nova, and when you do a deposit of them. When you want to do a withdrawal of them, you then burn those tokens and bring them back to Ethereum where they're unescrowed. And if you look at as Daniel was saying before, if you were to look at the total supply of those, you'd see that the Ethereum representation of the total supply doesn't change because you're just moving some around. You're escrowing some here or withdrawing them out or moving them around, but you're not minting and burning them. Whereas on Arbitrum 1, you would see the total supply changing quite a lot. So if you were to do minting on Arbitrum 1 with a token that you had bridged in this way, you would have more minted on Arbitrum 1 than was escrowed in the bridge. So you'd be kind of under collateralized in that sense. And also the total supplies would just kind of look out of whack. So what we wanted to do was to have a way in which we could do this kind of minting, but still keep this consistency with total supply. So we've just switched around the way in which this mint burn escrow mechanism works. So you create a token on L2, and then you escrow it on the gateway on L2, and that then mints tokens on L1. And then when you want to move them back to Arbitrum 1, you would then burn them on Ethereum, and then they get unescrowed on Arbitrum 1.
Yep. Yeah, exactly. So it's largely just kind of flipping the logic of what happens on which chain. And then, of course, once it's bridged on L1, now you have an L1 representation of an ERC20 token, and that can be bridged, however. And in fact, we also, we set up the gateway from Ethereum L1 to Arbitrum Nova, and that's just more of a, less unusual, less fancy bridging situation. And you can do whatever from there. But yeah, the important thing is that it's sort of canonical on Arb1, and yeah, I would say largely for this kind of so that the L2, so that Arb1 has direct knowledge of the supply cap. It also just kind of feels nicer that the Arb token is like truly native to Arb1 as opposed to something that was bridged over. But that's for, I don't know, for reasons I can't explain, it feels nicer. But the important thing was a supply cap. But yeah, this mechanism. I mean, another reason that projects have in the past wanted something like this. This is a specific thing, supply cap enforcement, but also there's projects that just like had a token that just started on layer 2 because they just wanted to deploy to Arbitrum 1 because Arbitrum 1 is cool. And then, after being live for a bit, they thought, okay, well now actually we'd like to be able to bridge this thing back to layer 1. So there's all sorts of bridges out there, of course, but we would like, to offer them a path to use the canonical bridge. So now using these contracts, projects can do that. To be honest, we probably don't make it too easy to deploy them at the moment. I'm not sure, but we can certainly help with that. But the contracts are there, they're audited, they work, and that's what our token is using. So yeah, hopefully that's something other projects can use for whatever. So yeah, so that's also some new stuff that comes out with the governance contracts and the DAO in general. Yeah, anything else on the Arb token we want to say? I'm trying to think. There was some talk. One thing that's maybe worth saying, maybe this is getting a little off track, but in terms of gateways, there's a subtlety here where like some of these gateways can, they can be one-to-one with a token and some can be one-to-many, meaning a single pair of gateway contracts can handle the bridging of many different tokens. They all use the same gateway, or a gateway can be designed so that just one token uses a single gateway pairing. For the Arb token and for the reverse bridge, it sort of expects there to be one token. And we sort of did that. It's largely, it's if you look at the code, you'll see that it's like some of the logic feels like it's designed so that you could open it up to many, but then we just restricted that. It's a subtle thing, but basically the thing there was just like simplicity, decrease the attack surface, and things like that. And there isn't much lost. It just means that for a new token, they have to deploy a new gateway contracts. But we wanted to just like eliminate any risks that we would even have to think about. Yeah.
Yeah, that's like also another reason because like being using like a L2 native token isn't like there's like multiple design that you can take like because like mainly surrounding like how do you want the total supply being tracked because like for most of the token they usually like have the total supply tracked on L1, so basically like for example you want to know how many like I don't know unit exist in like exists, then you go to like L1 and you go to the unit contract and then you see total supply, and even if it just get bridged to Arbitrum, you still have like the correct total supply on L1. But like for example, in this case, for now the reverse bridge, you have like the source of truth of the total supply being on L2. So like the one of the reason that we don't really want to like make that gateway to become like totally like everyone can use it. I mean you can still use it if you want to like deploy yourself, but then it doesn't make it like super easy to do it for now. Is that we are still like want to make sure the team know that like those trade off of like being an L2 native token or L2 or L1 native token or like being a token that's not native anywhere, and they have to understand that how like these work before they actually choose to use the reverse gateway to bridge their token to L1.
Yeah, right. Like there's a lot of variance here, and if we sort of advertised it as, hey, now we have a reverse gateway, we're kind of effectively making a lot of decisions that
yeah,
rather
they
projects
also
stop
like
and think about.
another thing is like if you have a reverse gateway on L1, then you also make because like the gateway can also mint tokens. That mean like whoever owns the
Yes.
gateway that can also like mint your token on L1. So that's like kind of also like another risk like factor that you have to consider when you try to like bridge your L2 native to L1 like among like a bunch of other design.
Yeah, exactly, right. So yeah, so that's if you don't understand that, you could fall into some weird design pattern. So yeah, and as you said, there's an interesting one that the ARB token doesn't use, but a token could use, where it's kind of there's no real native token, which means like there's no one contract that knows the total supply, and you just kind of mint and burn on both sides. Which there's nothing in principle wrong with that, as far as I can tell, other than it might look confusing. But that's another design. If we were to like start over, if we were to like if we were starting blockchains over, if they all collapse and we're rebuilding from scratch, we might want a standard to do something like that, where there's no notion of like a native place it is. We just deploy it on multiple chains, and then maybe now there's some hierarching way to track total supply. I don't know. That one problem I guess I haven't thought through enough. But if a token's sort of designed with a particular bridge in mind, yeah, you can just like the bridge is kind of part of the token. You can mint and burn on both sides, and yeah, maybe projects will want to do something like that for some reason. So yeah, it's sort of, I think that's like generally when it comes to token bridging stuff, we kind of lean on like it's a broad enough design space that if a project is going to use something customizable, we want them to understand and make those decisions themselves, as opposed to like here's a generic way of bridging. The one big exception to that is we do want to have a standard gateway, which is like, if you don't want to do anything fancy or funky, you can use this thing and it will deposit and withdraw the way you should reasonably expect. So yeah, so for those reasons, it is a single token gateway, but yeah, it's something projects can look at and use. Yeah. Cool. I see we're close to the hour, so we can kind of wrap there.
Yeah, there's one more thing
please.
I'd like to talk about as well, which is the concept of a constitutional and a non-constitutional proposal. So we have two types of proposal: those that affect the users on the chain, and these are constitutional proposals, and those that don't, and those are considered non-constitutional. And in its technical implementation, that results in us having two different governor contracts. One which governs and controls the assets that affect users, such as the underlying contracts on L1, things like that, and the chain owner on L2. And then this non-constitutional governor, which has actually different thresholds for reaching quorum. And that controls at the moment, its only responsibility at the moment is to control the treasury. So we also have some contracts around the treasury there. So yeah,
yes.
I was just going to point that out as well. So like a separate set of governor contracts, which is a lot simpler in Flow. They don't do this round trip through these different time locks. They just have a single time lock on L2, and that's what they do.
Yeah, no, that's a good thing to flag because we didn't really talk about that. And yeah, basically in terms of this, the implementation here looks much more similar to a more a more typical governance, a more a single chain governance system. Let's say that's on that would just be on L1, and that you go through the voting process, and then it just executes. And yeah, the Constitution in a more granular way outlines the difference and what counts as what. But essentially, roughly speaking, the stuff that's critical, the stuff that could potentially put user funds at risk, the stuff that's a big deal, this is constitutional, goes through the round trip, so users have an opportunity to exit. Whereas, yeah, the one thing now that the non-constitutional governor, not to be confused with unconstitutional, we get into legalese here a bit, but the non-constitutional governor can do is it's responsible for sort of like spending the treasury's funds. The idea being that that might be important, that might be a big deal, but those are spending of the treasury's funds doesn't affect you directly as a user. So withdrawing before it happens doesn't it's sort of a non-issue. The DAO might choose to sort of grant more responsibilities and more things to the non-constitutional governor over time. But yeah, there is that distinction set up. Also, that's all implemented. That's all live. Yeah. Cool. Yeah, I think in terms of like rationale and implementation details, that does give a pretty good overview. And yeah, I definitely recommend people take a look at this stuff because it's new stuff. It's been audited and so on, but always good to have more eyeballs and more people understanding it. And yeah, unless there's any other things we want to shout out there from Chris or Harry, we can wrap.
Yeah, I think I can like quickly talk about also how we distribute the airdrop. So like usually when you have like airdrop, you usually use like a thing called a Merkle drop. Basically, like start from the Uniswap airdrop. You upload like a Merkle root of the airdrop details, and then everyone want to claim, they just supply a proof to that root, so that to prove that they actually deserve, like entitled to like certain amounts of the airdrop. This is like good in like the context of Ethereum L1 because like you like storage on L1 is super expensive. So if like I have to airdrop like to like a 10, like for example in the Arbitrum airdrops is like 600,000 recipients. So if you have to like set 600,000 to transfer, then that would be like super expensive. But like because like the execution and storage is like relatively cheap on L2 like Arbitrum 1, so like the strategy we use in distributing this airdrop is instead of using like a traditional like Merkle drop, we actually have like a token distributor that set the token amount, like the mapping of the address and token amount directly to the contract. And when the user want to claim, they can just like call claim and that in the function. And we'll also like our UI will also like guide the user to like delegate in the same transaction, so they don't have to like calculate the whole Merkle proof, and they like save like, because on Arbitrum 1 it's actually much more expensive to have like L1 core data because you have to post those to L1. So a major benefit of it is that the transaction size will be the core data of the transaction will be much smaller because you don't have to include a full Merkle proof. You just need to like basically just need to call claim and also include a signature for the delegation, and that in aggregate will save like is much cheaper than like individual claim of a Merkle drop.
Yes, this is an interesting detail where it actually, even though, so, assuming that enough users actually claim, which we can't exactly predict, but we expect a lot of them to do so. And I don't remember the exact math, the arithmetic here, we did it, but as long as a reasonable number of users claim, first of all, doing it this way is, it's cheaper for users. We incur some of that cost ourselves when we deploy for this process, and then users don't have to pay it themselves. We're happy to do that because we love our users, and so we're happy to take some of that cost. But as Harry said, yes, the actual net cost, it turns out, as long as enough users claim, is actually lower than it would be if we were doing a Merkle drop. So we decided to do that. It just meant setting it up took a bit longer for us, like a few more hours. That was one of the practical downsides, but that's all done. So yeah. Yeah, so it's not a Merkle drop. It is an actual mapping drop, which again just what users will experience there is it will be cheaper for them to claim. So another little fun tidbit. Cool. You are all experts on the governance contracts now. That was fairly granular. But yeah, thanks for listening all. There'll be at least one more space today later with the Prism folks, maybe more than one. And I think we will wrap there. Take care and enjoy the weekend.
Thanks. Bye.
Bye.